and welcome for the Collective Minds and Machines Exploration Challenge Hangout. I'm Jason Crusan. I'm the Director of Advanced Exploration Systems for NASA within our Human Exploration and Operations Mission Directorate. So in my group, we are developing a lot of the next generation technology and capabilities that we need to send humans beyond low Earth orbit. And today, we're excited to be talking about our latest in a series of challenges discussing our Collective Minds and Machine Exploration Challenge. It's a new open innovation and crowdsourcing challenge where we're asking you to help create a machine learning algorithm that will help us accelerate discoveries for NASA to use, but also for the science community to use here back on Earth. We're going to give you some brief background about what we're doing, and then we're going to open up the floor for questions. I do want to encourage you, if you want to send a question in, send it in through Twitter using the #NTL hashtag. And again, it's the #NTL hashtag. Send your questions in that way, and we'll be able to answer your questions live here on the Hangout. Starting off, a little bit of the background of why NASA uses challenges. Obviously, we have a lot of different challenges in order to send humans into deep space and a lot of our science objectives at NASA. One of the areas that piqued our interest in open innovation is how do we involve the public in helping solve those problems from a involvement category, but also from wanting to get great, excellent ideas and actual real solutions from the public as well. We've seen this a lot of over the years at NASA, and in fact, every time that we have a challenge or something out of a mission, we actually get a lot of unsolicited feedback and such. So we were looking at that as a mechanism of how do we actually do that up front to actually help develop the systems that we need to send and execute our very difficult missions. So in order to facilitate this, we stood up a thing called NASA Tournament Lab, because NASA doesn't do this just by ourselves. And you'll see today we have our partners with Harvard and TopCoder and the University of San Diego with us for this specific challenge. And I'll let them each explain a little bit about what they do. We'll start with Dr. Albert Lind.
All right. Well, thanks for having me. I'm excited. This is a huge day for us. You know, it's the next evolution of how I think of the future of exploration. I'm a research scientist here at UC San Diego, and also I'm very proud to say an emerging explorer with the National Geographic Society, which means that every day I try to take whatever I can, you know, from technology that exists to technology that we're inventing to ways in which we think about science and apply it to exploration, to search and discovery, to try to push the limits of what we know about life on this planet. And you know, over the years, the things that I've focused on have been the discovery of right? I've spent the last 4 or 5 years now trying to investigate a place that has been forbidden to go to for 800 years. The homeland and actually the ancestral lands of the Mongols, of Genghis Khan, right? And in doing so, we've been trying to do this in a way which respects the local traditions of Mongolian people, which mean that we have to be completely non-invasive in our archaeological surveys, right? But we're looking for a needle in a haystack. We're looking for something where, you know, not only is it buried within a deep amount of, you know, data and information where we don't really have a clue of where it might be, but we also have to look in a way where we don't pre-assume to know what we will find is actually what we think it is, right? I mean, we don't have a definition of the characteristic of what we're looking for. So when we use satellite imagery to survey huge vast quantities of ground cover, we have to try to tap into the minds of many of our friends and colleagues for their human perception, to look for what's different. And in collaborating with NTL and with the group, you know, through the Harvard Business School and TopCoder at NASA, you know, what I see is an exciting opportunity for us to take what we've learned from crowdsourcing and from tapping into these massive pools of human perception and feed that into a new paradigm where machines and humans are working together, where some of the challenges that we face don't have enough eyes to solve them, where we're trying to take on the challenges of our big data avalanches that we face today, but in ways that are collaborative both across large networks of people and also in which we as those networks can leverage the most advanced technologies possible. And the reason for connecting with NTL is that we have no idea what those advanced technologies would be anyway as well, right? So we have to tap into the open innovation forums that exist out there and think about how, how you as a community can actually help us come up with the best answers and the best solutions to this challenge. So it's a great pleasure to be here, and I look forward to spending the next hour talking with you guys.
Okay, next I'm going to have Karim, who's our director of the Harvard NASA Tournament Lab, talk a little bit about his background and also how the NASA Tournament Lab came into being.
Sure. So thanks, Jason, and thanks to all of you for joining us today. So the NASA Tournament Lab came about as a way for us to take the lessons around crowdsourcing, around the use of contests and communities to solve problems, and apply it to real problems from real organizations like NASA. And the arrangement was basically that we had done some pilot prototype tests with TopCoder and NASA, and we found really good results from a technical point of view. And what we decided to do was say, how about we scale this up in two ways? One is scale this up so we can take in more problems for NASA and a diverse set of problems for NASA, but also for us to do real social science around them. So we're trying to build out both our understanding of how contests work, what are the motivations for people to participate, the incentives, when do contests fail, and we can do that in the setup of a real-life laboratory that is TopCoder. From our relationship with NASA, we've now actually worked with some other federal agencies as well, and you've seen some of those challenges on the TopCoder platform. And what we're really trying to do is try to take mainstream crowdsourcing as a viable toolkit for organizations to use on a regular basis. That we shouldn't be thinking about this as a substitute for what happens inside of a company or an organization, but a real complement. And our work here is to really show this happening in a wide range of settings, and with our relationship with NASA and with TopCoder, we really sort of shown to the world, to the technical communities that we interact with, that in fact, we can create robust, amazing solutions for some very significant technical challenges. It's a ton of fun and a real privilege for me to be working with NASA. I always wanted to be an astronaut growing up. Never will become that, I don't think, unless the space program expands greatly or I earn a few million more dollars to, to go into space. But certainly to work with NASA, to work with Jason, and to really take on concrete problems faced by NASA, and then to have them participate in a system that helps solve them is quite the privilege. Similarly, with TopCoder, it's been an amazing relationship for us from a research point of view. They have really helped us understand the dynamics of contests and tournaments from a real sense. There's a lot of theory, a lot of models about how contests work, but very little empirical evidence. And we've been very fortunate to be having worked with the TopCoder community and the TopCoder company on this. And then our relationship with Albert came about as our school was exploring new models for collaboration. And we had a visit out to Albert's labs out in San Diego, and that's where we were exposed to his ideas, and it was a natural fit. It was sort of like, wow, they've got all this crowd-labeled data, and let's take the best of the crowd-labeling efforts that Albert has done so well and tie it back to what the TopCoder community does well, which is machine learning. And let's do TopCoder from crowdsourcing for both ends, both from the generation of data as well as from machine learning. So I am super excited about this this project, and really looking forward to your questions and to your participation. More importantly.
Great. Last but not least, we wouldn't be able to do any of this without actually having a community of really excellent solvers to help us contribute to this. And that is enabled through our partnership with TopCoder. And Andy, over to you.
Thanks, Jason. Hi, I'm Andy Lamora. I am Senior Vice President of the Government Platforms at TopCoder. And as Karim and Jason mentioned, what we do is power the NTL, the NASA Tournament Lab. And it's really exciting for us to be part of this because how many people get to work on a NASA problem? So by bringing these challenges to our community, we allow people all over to have a crack at a problem that they probably never thought they'd be able to. And the types of solutions it brings are amazing, and it's exciting, and we just love being a part of it. So kind of in keeping with my company's function of bringing a crowd to NTL and to NASA, today I'll be bringing questions from a crowd to the panelists for this challenge. So without further ado, I think we can go to the crowd, right? So please follow along on Google Hangout. If you have any questions for us, send them in on Twitter with the hashtag NTL. And as they come in, we'll be reading them off, or I'll be reading them off. So let us begin. First things first, I have a question here for Albert. So Albert, has your research by using crowdsourcing produced any new discoveries?
Yeah, absolutely. I mean, it's not just a. When I think of crowdsourcing, I don't think of it as a solution to solving problems of scale alone. I think about it as a new method for tapping into the unknown, right? Because unlike machines, humans are very good at trying to figure out what something is when they first see it, just based on instinct. And what we used in our last platform to tap into that was a process where we asked many people to stare at a single piece of imagery and tell us in parallel what they saw in that imagery, whether or not it was something strange, modern, man-made, natural, and they would tag these things, right? Then when they finished tagging this little piece of information, they would see what the people around them had said about the same piece of data, but they couldn't change their answers, right? So now I have a method in which I can use a mathematical, statistical method to see where clusters of agreement emerge in the highest density, right? And I can actually ride out on horseback every single day into the field and check out exactly where that corresponded to on the ground. And over the process of doing this in the amazing landscape of Mongolia, we discovered over 55 archaeological sites that where we identified these things across a massive region. Some of which we are pretty excited about. A lot of that work is now being reviewed within the Ministry of Culture in Mongolia, and we'll figure out what we can say about that later. But what I got even more excited about after that was the fact that this method didn't just apply to archaeology, right? I mean, it could be used in archaeology for other areas, and that's what we continue to do. Places that range from the Mayan civilizations of Central America to Egypt, but we could also use this beyond that, right? I mean, the method of tapping into large quantities of human perception for discovery in the unknown could be applied to mapping neural pathways in the brain, or to mapping the planets that we start to observe at higher sensitivities with better sensors and better telescopes, right? I mean, this is all an era where we're producing more and more information, and the processes and the methods with which we use to analyze that data is going to define the kinds of discoveries that we make and the level of discovery that we make. Most recently, my friends over at Digital Globe have been using a very similar method to search for the schooner Nina, this lost schooner that went missing in the Tasmanian Sea, and I really hope that they end up finding this, but it just shows you that we as a community can solve big problems, real problems, if we just think of new ways in which we network with each other to take on those challenges. And the discoveries that we've made thus far with this methodology have just continued to astound me. And I'm just excited to see what happens next when we can tap into a collaboration with the machines to amplify even further what this power is.
Thanks, Albert. And the second question kind of conveniently builds on your experiences there. So with your work on the reviewing or looking for ancient structures, and given what we saw recently with the Boston bombing, where people were using images from Twitter or from whatever sources were available, and considering the search for the schooner, what are some of the greatest barriers to using this approach, to using crowdsourcing? What are some of the difficulties you've had?
You know, that's a very appropriate question, and I think you know, it all comes down to the way in which we structure and architect these big networks and how they collaborate with each other. Careful structuring allows us to avoid turning a crowd of helpers into a mob, which is, you know, something that was somewhat, you know, highlighted as a potential outcome of what happened in Boston sometimes, right? So in Boston, we had a case where people were looking at imagery online, but in some cases, the analysis was so emotionally driven that you know, we didn't have the mechanisms with which to try to create these statistical, valid verifications of the information that was coming out of that. What we're doing here is we're using architecture in which, you know, you can see certain things and you can work and network and cross certain parallels, but the way in which your data evolves allows it to be something that's safe and secure, and also is truly self-guiding in terms of, you know, this crowd is no single individual in the crowd is deciding who might be or where this thing might be, the anomaly that we're looking for. Rather, it's the group as a whole agreeing upon a location independently, and that emerging an answer, which we've found to be far greater percentage of accuracy from that kind of methodology. So it's all about structure, and that's a lesson that I've learned. You know, and you know, I think we can continue to evolve those structures to really push the limits of what our interconnectivity can do. We just have to be careful about how we do it.
Yeah, if I may add to this, I think it's I mean, what we know is one of the failures for crowds is lack of governance. So if you think about both sort of communities, open source software communities, there's a very strong implicit governance model that exists in open source software communities, or even Wikipedia, which has a very ornate governance model put into it. Similarly, you know, in contests as well, there is a governance required. There has to be some way to organize the inputs coming in and some way to detect false positives. Oftentimes when we work together, you know, in all the projects we do with TopCoder, and a big effort also with Albert was to sort of say, what is going to be the scoring algorithm? How will we know when we get the right answer instead of a false positive or a false negative? So that's where, you know, governance matters a ton, and that's what almost, you know, decides if a project will be successful or not.
So that brings up a question. We've talked about crowdsourcing. We know TopCoder does contests, and Tournament Lab has the word tournament in it. So one question is, what's the challenge? That might be a question for you, Karim.
What's the challenge?
What is, in the context of what we're doing here, we've used the word like contest and a challenge. And so from the view of somebody who wants to participate, what is a challenge, and how do we use it here?
Oh, so challenge it just specifies the problem. We use these words intermixedly, meaning that, you know, we'll refer to a contest, we'll refer to a tournament, we'll refer to a problem, we'll refer to a challenge. And all those elements are basically saying that we are setting up a structure where there's a defined problem, a defined set of evaluation criteria that are objective, that we have developed, and the challenge is to solve the problem as stated on the site that creates the best score based on our evaluation criteria. That's as simple as that. People will use challenges, people will use prizes, people will say tournaments, people will, all those terms. Basically, the fundamental component is it's a race. There's a time amount required in the sense of it's going to be over a certain period of time, and then the best performing solutions will win.
Yeah, so in this case, a little bit more on that. In this case, we have a singular kind of what's called a marathon match that is looking at creation of this machine learning algorithm based on the data sets that Albert's team has provided to us. of actually recreating basically a machine learning algorithm that can actually learn from these type of data sources out there. And it's a singular kind of challenge or tournament. In other cases, we decompose problems into a series of smaller challenges in order to kind of split apart the problem. And sometimes we'll call those tournaments or individual contests that then go to an overall challenge type thing where we're getting. But it all depends on the scope and the size of the problem. We do end up using the terminology pretty intermittent, but you can actually, there's a little bit of a hierarchy to this too in some cases when you want to split it apart. But in this case, it's a singular kind of marathon match that we think we can get good results from.
Thanks, Jason. So follow-up question for you then. NASA is literally the home of rocket scientists, right? So it's even an idiom. Why does NASA need challenges?
So there's a couple of different ways. So I mean, we're not replacing what we have within the NASA family. NASA and its normal academics and industry and such that we work with every day. But what we want to be able to do is harness the power of all the people that are out there to be able to accelerate the pace at which we can learn. So no matter, there's a quote out there, the Joy's Law quote that any one of us here talk about all the time, that says, no matter who you are, the smartest people work for somebody else. But really, the smarts come from a very large community. And in aggregate, you can get a much better result by the increased number of people you can engage with. So we look at a problem from a certain perspective from in-house, but somebody from the outside may bring a total different perspective to that problem, or a different approach or knowledge they already have and apply it to our problem set. And in essence, that allows us to accelerate that pace of solving a solution, like in this case, an algorithm. In other cases, bringing a completely different concept of a new idea of how to go after a problem. So it's that kind of broad search kind of capabilities of being able to find best ideas anywhere in the world.
Thanks. And so one more follow-up. I know that we talked about it a little bit during introductions, but with respect to what you just said, what are some of the specific things that you're looking for out of this challenge, and how do you see people at NASA using it?
Yeah, so there's obviously a great application in what Albert's just doing with his exploration here on the ground. But at the end of the day, what we'll end up creating is an algorithm that can be trained through crowdsourcing data. So if we had, say, an image set that we're looking for asteroids, we have a lot of sky survey data where we survey the sky, and we're looking for things that change in a peculiar way in order to figure out an object that's a near-Earth object or asteroid coming across the sky. Right now, there are algorithms to do some of that, but you could actually enhance that through crowdsourcing efforts and actually increase the ability for that image processing algorithm to actually be created even better. The same thing could be applied towards Mars, Moon, or on the surface of Mars, or the surface of the Moon, or any planetary surface for that matter. If you wanted to understand how to characterize craters, impact zones, find unique features on a planetary surface in a certain way, but you can't search the 2 billion plus images. Even through crowdsourcing, you can't get 2 billion images processed. You could take a small set of those, say 100,000 images, 200,000 images, process those through a more crowd engagement period, use that crowd data, then feed and train your algorithm in order to then run on the rest of the 2 billion images that are out there. So what we are looking for is an algorithm that helps us scale past crowdsourcing's inputs of a couple 100,000 images to the ability to go into the billions of images and process through that, but really using the human intellect in order to train that algorithm.
Yeah, let me jump in for a second as well. You know, this concept, right, where we're trying to tap into the human intellect at scale is something that has such broad applications in space and in earth science and in in any type of big data analytics. But the answers don't necessarily come from a single place, right? I mean, it would take you more than a lifetime to try to become an expert in every different type of machine learning or computer vision application out there or process out there. And what we're doing, I think, with this challenge is not saying that it's, as Karim said, it's not a substitute for in-house innovation. It's a complement to all types of innovation, and that we can now say, to you, the whole community out there, let's try every different process possible and see which one emerges with the most efficient, most intelligent algorithm to learn from, crowdsourced data, right? And the applications afterwards that will follow, that's a second part of this. But what we're trying to get from this challenge is to tap into as many ideas and as many avenues as possible in the ways in which you might develop this algorithm and come up with the best solution from this open type of innovation. And that's where it gets really exciting.
So clearly one of the benefits of a contest is to get solutions from lots of different minds, lots of different people, which kind of begs the question, which I'll direct to you, Karim, of what kind of experience do people need to try this at all, to participate in a challenge?
Our results of our analysis of a variety of crowdsourcing platforms show that, in fact, the winners tend to come from areas that are outside the domain of the problem. So, I think if you can code, you understand machine learning, and you're excited by the contest, I would encourage you to participate. What's very cool about this setup is that you get immediate feedback, both about how well you're doing, how well your coding is going on, but how you also rank and stack against everybody else. And I think that's the real benefit. Oftentimes when we're working inside of our companies or in academia or in a lab, we don't get to compare ourselves. We don't get to see how other people might do it or how other people might approach the problem. And the only way that you're going to learn about this, and the only way you can really improve yourself, is by participating and hanging on, and then trying to improve your own understanding of the problem. And then at the end of the contest, what's so great about these settings is that once the contest is over, the first thing that happens in the TopCoder community is the post of share your approach. So people immediately start sharing their approaches and learn from each other as to what worked and what didn't work. And that kind of a teaching, that kind of a learning, you can't get even at Harvard. You have to actually be involved in the problem, be struggling with it over the time period, and then learn from other people to sort of say how their approach made a difference. And so, I think that's what I'd recommend. And we know for a fact that one of the great things that crowdsourcing unleashes, that these contests unleash, is diversity of perspectives on how to solve the problem. We'll get lots of entries, but within that are many, 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 many different ways to attack the problem, and those things go a really long way to make you a better programmer, to understand machine learning, to understand how this very intricate data sets can be used for these types of applications.
Does anybody find it funny that we're crowdsourcing the learning of crowdsourcing?
Yeah, it's pretty cool.
Well, there you have it, folks. Come to TopCoder. It's better than Harvard.
I didn't say that.
You a quote to sign. All right, I'll take my TopCoder hat back off. Well, I'll put it back on just real quick for one minor thing, and that's that this particular challenge is pretty language agnostic. So folks can compete in this thing in Python, in C++, in VB, in Java. The idea is to get the best ideas, not necessarily the ones written in a specific language. Okay.
Can I do assembler? Can I send something in assembler?
No. Oh. we're not evil. Okay. So one other question that is coming in here is we're all familiar with, or most people are familiar with, the Ansari X Prize, or Ansari X Prize, right? It was one gigantic prize to accomplish this one gigantically difficult task, build a rocket. Is that the way all challenges are formulated, or do they have first, second, third, and so on?
So I'll talk a little bit about what we've done, and then Karim can talk about in general and how too. But NASA actually runs kind of challenges and prizes on multiple different scales. Our NASA Tournament Lab activities are centered around software and algorithm type solutions, with prizes in the order of $10,000 to $30,000 type ranges, and they're kind of commensurate to the amount of time that somebody needs to be able to put in order to solve that problem. We also at NASA have other large-scale prize initiatives like our Centennial Challenge program, going after things like green aircraft, green aviation challenge, where people are actually building full-fledged aircraft, much like the Ansari X Prize is building a spacecraft. And the commensurate prize for those goes into the $1 million type plus range. So one of the things that's really important with this is, yes, you need a proper incentive, but you can over-incentivize as well. And so you need to kind of pair the size of incentive that would get people to participate with the level of difficulty of the challenge or how complex the challenge potentially is. And you got to be careful in that, because sometimes you can actually inadvertently create a barrier to participating too. And say if you had a really hard challenge and you just wanted to get headlines, and say it's a $100,000 or a $1 million prize, well, people can find that intimidating. Do I as an individual have a $1 million idea? And that may actually prohibit some people from actually participating just because they don't feel that they can participate. Where in other cases is, does everybody have a $10,000 idea or $30,000? Absolutely. Those ideas can come in. So there's a little bit of a pairing of the incentives along with the types of challenge that I ran.
Thanks, Jason. So, Karim, I think you touched on it before, but we know that you're the principal investigator for the Harvard NASA Tournament Lab. Can you explain a little bit of how you're planning to use this algorithm and what sort of research you're gathering with this?
No.
Okay. Well, moving on.
It's a secret. No, our hope is that we're actually going to be able to write a scientific paper about crowdsourcing for both sides. So, in collaboration with Albert, and sort of show how crowd labeling enabled them to actually, make some very important archaeological discoveries. But then to bring it back to sort of say that, in fact, this data is actually very valuable, and we can create general-purpose algorithms through crowdsourcing on the intellectual side, in terms of problem-solving side, to then come back and say that, in fact, this data could be used to then create new algorithms on how to assess this imagery. So our hope is that as soon as this contest is over, to then engage, maybe even with the crowd at TopCoder and elsewhere, in writing up a paper that shows both sides. And I think that's where there's going to be a lot of interest, because as Jason said, as Albert said, that in fact, we are living in a world where image analysis is exploding in many applications, many dimensions. You think about medical imaging. That's all about human beings looking at images, X-rays, PET scans, MRI scans, and then deciding if there's a tumor there, there's a fracture there or not, and so on. So there's a pathology studies, you name it. There's a ton of applications just in medical imaging which could potentially really benefit from these types of algorithms. If you just think about it, hundreds of thousands of radiologists around the world are always labeling images, right, and coming up with diagnoses, right? This could actually be revolutionary in that side. Same thing in detecting cracks in jet engines, you name it, a range of settings where, in fact, these algorithms could be put to use. But we need both the human side of labeling with the machine side of taking the minimal amount of labeling required and being able to sort through and scale up to the terabytes of data that we're now capturing. So it's very exciting, and I think I'm really hoping that it becomes a great contribution to scientists. And our hope is actually, what's important for us is, both for myself and for Albert, and I think all of us here, is that we don't want this kind of an approach to be viewed as something exotic, something on the sidelines, like, oh, how interesting, look at this prize-based contest, look at this crowdsourcing thing. Our objective is to make this go mainstream. Let's find a way, let's show to our colleagues in the academic world, in the industrial worlds, how you can combine both of these together. Because I think that's where, for us, the excitement is. Right? we're convinced that this works. This works really well. We've done so many contests on so many platforms that this works really well. And now we're going to push it to the next level, and then again show to our colleagues that in fact this is an approach that actually makes sense and can be scaled up.
Absolutely. Yeah, I'll jump in with a little bit of my excitement about this as well, if you don't mind. The questions that we can answer are different than the ones that we've tried to answer in the past. In that, a lot of times we take for granted just how amazing human perception and intuition is, and especially in image analysis and image categorizations. And when you go through and think about a doctor putting something on a medical imaging data set, that takes a huge amount of human training and experience to do so correctly, right? But to scale that up, you can't automate that right now, right? I mean, there's no way in which you can automate that intuition, because it's building that visual perception is building upon everything that person had experienced up to that point, right? Everything they had learned. But what we can do is say, well, maybe we can start to extract out what is the essence of what they're identifying, right? And that's what we're asking the crowd here to do, is to figure out what is the essence of what they're identifying with as few of those examples as possible from that doctor or the network of doctors, right? In our case, it's people helping us use their human intuition to see what was strange about a location in a piece of satellite imagery, right? What looked ancient, what looked weird. We didn't give any kind of example to train an individual with what was weird or what was strange. We just asked for that human perception, and now we're asking the crowd of coders to come up with a way to just extract the essence of what they identified, right? And the kinds of questions we can answer from from that kind of process, I think are broad and wild, and I'm excited to see what comes of it.
So one observation then is clearly challenges are not only programming. They're also, or building rockets. It's so in your case, Albert, where you have amateurs annotating images, and Karim, it sounds like maybe someday there's some kind of convergence with doing that with medical imaging as well. So that brings up one of our, I think we're reaching the end of our questions, although if anyone's following along that would like to ask a question that hasn't, please be sure to post it to Twitter, #NTL, and we'll be sure to read it off here. So one question that I know that we're all burning to ask you, Karim, is what's the craziest outcome you've found using crowdsourcing?
Craziest outcome?
Yes.
I mean, I think, I think two recent examples. I mean, I think our Longeron challenge on, to come up with the algorithms for peak angles for the space station. I mean, I think it's incredible to think that in a 2-3 week challenge, I don't even remember how long we ran the challenge for. We were able to, come up with very robust algorithms using very unique approaches that meets and in some cases beats the requirements that have been set by NASA. And so that in itself is just so to be quite honest, I'm like, that's my default now. Like if it doesn't improve, doesn't reach or improve by orders of magnitude, I'm like disappointed, and I've yet to be disappointed. So it's always exciting to sort of see that come through. So I think the Longeron challenge is a great example of us, using a scaled down model, using very difficult circumstances, very difficult data, very difficult problem, and the community of more than 400 submitters did an amazing job of solving that problem. I mean, it's just like, it's unbelievable what they were able to get done. Similarly, a few years back, we ran a challenge in genomic analysis and sequence alignment, and we published a paper on this, and we are orders of magnitude better than the Harvard solution and then also the NIH solution, with people with relatively no background in computational biology. So for me now, it's sort of like, with the lab and so forth is, this is such such an important way for us to solve at the moment technical challenges and solve them really well, that we should be, again, and this is part of our mission at the lab and the work we're doing with Jason and NASA and with TopCoder, is how do we make this go mainstream? How do we encourage, how do we create the pathways for scientists, for engineers, for technologists around the world to see this as a great opportunity to move further their technical projects. At the same time, to invite people from around the world to participate in problem solving. The fact that we can actually post real-life NASA challenges, the fact we can post real-life National Geographic challenges, the fact that we can invite many more people into the problem-solving process than before is just fantastic.
Thanks, Karim. Well, folks, I don't see any additional questions on our NTL stream. So I'd like to throw one in there that came in through one of our other channels. Give folks a chance to ask any more questions on Twitter before we close it out. And my question is this: here at TopCoder, one question we get a lot of, and that we've gotten specifically in regard to this challenge is, when you're looking for a collaborative result, or you're looking for a problem that you're trying to solve a problem that typically requires a huge amount of cooperation or collaboration, how can you possibly run a contest around it? So that's one question I posed to the group. Do you limit your challenges to only those things that a lone agent working at home would be able to solve? Or is it something that you think can work when appropriately asked in the scientific field as well?
So some of the challenges that we ran, we obviously go after and structure things as an individual competing. In other cases, when the problem is more complex or requires multiple disciplinary approaches, teaming arrangements can also come into play. And in fact, a lot of our other challenge types that are not the software and algorithm ones are actually allow team type approaches and such for that. In this case, it happens to be individuals. The resources that are needed for this can be readily had with a computer at home, and there isn't a need for a real big teaming type approach. And there's a bit of the incentive piece that probably Karim could talk about as well, about how individual versus team incentives do play out in this as well. But it really depends on how you want to orchestrate it. What kind of involvement do you want from a community? What are the community norms as well? So if you're using an existing community that's out there, there are certain norms that they are used to. And in the case of our NASA Tournament Lab, the community we're using obviously is TopCoders, which the community norm is individuals competing. And there's actually individual achievement badges, and there's a sense of kind of self-achievement there. And that works very well with that type of community. But there's other methodologies as well.
Yeah, I think just to build on what Jason said, I mean, I think there's various ways in which you can have multiple people participate in solving the same problem. One, of course, is, and we've done this, is to go, release intermediate solutions for other people to work on. So you have stage one, people are competing, then the winners of that stage one are then released, that code is released for stage two, and then people look at that, learn from that, and improve upon that. So that's one way you can bring in a bit of cooperation in a fully competition mode. I think a lot of it depends on the problem you're trying to solve as well. You could take a problem which has multiple dimensions and requires multiple skill sets, and that may be best suited to folks that have those dimensions available to them in their teams and potentially work with them on that. But the issue often becomes is, how does somebody find those other teammates, and how do we make that happen? And we've actually done some scientific work in that space in multiple dimensions in that area. And then you can also run purely wiki-like challenges where everything is available for everybody else to use and reuse, and we've also done that as well. I think for us, the first concern always is that do the incentives match the context, and does the context match the character of the community? And so we will always create, when we run most of our TopCoder work, is to take problems that an individual can solve on their own, and can do it in a competitive fashion. But that hasn't prevented us from actually, even in the TopCoder platform, to in fact run very interesting cooperation type scenarios inside of a competitive framework.
And in this particular case, just working with your teams across HBS and NTL and NASA, people, world-class data scientists like Renat Sergeyev and some of my colleagues here, like Gert Landry, to come up with the strategy in which we ask the question. Our problem statement has been developed over a series of months, of thinking about how we can ask the technical question in the appropriate way, and it's, I hope you guys find it interesting.
So we've had another question come in over Twitter, which I'll read off now if we still have time. I think we do. And that question is so I think this is the contest formulation. Is it a significant limitation factor for critical thinking, especially for large data mining problems? Is that enough? Jason, would you like to take a crack at that one? Or do we need to form it a little better?
Yeah, is it a significant limitation factor for critical thinking, especially for large? Well, critical thinking as far as making decisions from large data sources, just to have large data by itself is, and in fact, in a lot of cases, completely useless. If you can't actually ascertain what is in the data and actually get context of the data in some way, then your ability to do critical thinking and decision making off of a data source is extremely challenged. I mean, in many ways, what we're trying to do with this challenge is to set up methodology where we can look at taking raw data sources, put it out there, allow the human intuition and such to actually look at things and items critically, identify patterns and or pieces in the data that then we can actually train the algorithm and then go off and find and run that on the entire data set. And from that, then you can start doing critical decision making and critical thinking about that data set versus just having the data. In NASA, we bring tons of data back on every one of our missions, more data than we could ever analyze, or even the science community in general could actually analyze, in hopes that someday people will be able to go back and analyze that data and find even more scientific discoveries in these kind of open data sources that we have. I think that gets at the question that was being asked.
I think so. And I'm checking our list here, and I think that concludes our questions. So, Jason, can we turn it over to you?
Yeah, so if we don't have any more questions, well, you can, obviously, if people have questions after the fact, please keep on sending them in using the hashtag NTL. Also, I want to encourage you all to go and actually go and sign up for our challenge and participate on it. What you're looking for is it's a marathon match entitled the Collective Minds and Machine Exploration Challenge. And hopefully help us, help NASA, help Nat Geo, help Harvard understand the past so we can actually prepare for our future data sets that are coming in with this. And I'd like to thank you all for participating, and I'd like to thank our presenters and our partners here that are on the phone today, and encourage you all to, if not this challenge, we run many others, and participate on those.
Great, thanks a lot.
Thanks.
Thanks a lot.